Hey guys, today's lesson is going to be about how to solve systems of linear equations graphically. So there's actually three different ways of solving systems of linear equations that we're going to be looking at. Today we'll learn how to solve graphically. We're going to do more work with solving graphically tomorrow probably. And then we're also going to learn how to solve using something called substitution and using something called elimination. We'll be looking at those in kind of the next couple lessons. When it comes to a test or a quiz, you can pick which of these methods you like to use. So you don't have to be great at all of these methods. I personally hate solving graphically because I don't like graphing things. So if you don't like solving graphically either, you don't have to after this lesson. As long as you can read a graph and read the solution off of a graph, that's really the important thing to get out of this. But anyway, let's get into today's lesson. Okay, so this is lesson 7.2, solving systems of equations graphically. So you do have to start, if you're given a word problem, by writing out your system of equations, which is what we did yesterday. And then to solve graphically, you must rewrite both the equations in the form y equals mx plus b, or slope-intercept form. The reason you want to do that is because the next step will be to graph each equation by plotting the y-intercept and then using the slope to rise over run to the next point. By the way, when you are putting your equations into y equals mx plus b form, it doesn't matter which variable you put in the y and which you put in the x. You don't have to like identify an independent and a dependent variable. Just make sure that if you pick like, one letter to be the y, that's the y in both of your equations. Anyway, after you graph each equation, your two lines will cross or intersect at a point. Whatever point they intersect at, that coordinate is the solution. And then you just verify your solution from there. So let's run through this example here. So at your restaurant, you charge $12 for lunch and $20 for dinner. One day you sell 11 meals and make $180. How many of each meal did you sell? So once again, I'm going to start with my let statements. So let D be the number of dinners. Let L be the number of lunches, since that's what I'm trying to figure out, how many of each meal, so how many lunches and how many dinners did I sell. The first thing, or the easiest thing to write is just the fact that I sold 11 meals, which means that the number of dinners plus the number of lunches must have equaled 11. And then the second equation is the one that has to do with all of the money, the $12 for lunch and $20 for dinner, and the total of $180 that I made. That tells me that I can write the equation 12 times the number of lunches plus 20 times the number of dinners is going to equal the total amount of money that I made. From there, I'm just going to pick a variable to isolate. So I can isolate either my D or my L. And by isolate, I mean like get it to like the Y position of Y equals mx plus b. Again, doesn't matter which one. I'm going to isolate the D, but you could isolate the L. And I do that in this case by just subtracting to move the L to the other side. And that leaves me with D equals 11 minus L, which I will just rearrange into negative L plus 11 so that it's in the form Y equals mx plus b, where like D is like my Y. You want to think of it that way. This is kind of like my Y equals mx plus b. So D is my Y and L is like my x. On the other side, in the other equation, I'm also going to move the 12L to the other side by subtracting it. which leaves me with 20d. And then once again, I'm going to rearrange these so that I have my mx plus b form. And then I need to divide everything by 20 to get the d by itself. So d equals whatever, -12 divided by 20, that simplifies to -3/5 if I divide them both by 4. And then 180 divided by 20 is 9. So these are now the two equations that I will be using, both in slope-intercept form. So now that I've rearranged my equations into slope-intercept form, I need to graph them both. If you have graphing paper, it would definitely come in handy right now. But if you're like me and don't, you'll just have to do a rough sketch of the graph. So let me get my graph sketched out here. Okay, so I've sketched out a graph here. I've gone up to like 14 and over to 12, just based on what my b values are. So I have a b value of 11 and a b value of 9, so that tells me I have to like go up to at least 11. Also, I want to label my axes. I'm not going to call this my y-axis. I am going to call it my d-axis because I have replaced y with d for my equations. Oh, I forgot my L over here. Which means that this isn't going to be my x-axis anymore. It's going to be my L-axis. Okay, but that's really as far as you have to go with labeling this. Then I'm going to start with this equation here, d equals -L plus 11. Again, I start by plotting my b value, which is that 11. So that's going to be about there between the 10 and 12. And then my rise over run, because this is just -L, really there's like an imaginary 1 in there, which means that the rise over run for that is -1/1. So I'm going to go down 1/1. Down 1, which would be like there. Down 1/1. Down 1/1. Down 1/1. Down 1/1. You get the idea. I'm just going until I hit the other axis, okay? Okay, then I'm going to graph my other line. I'll start by plotting that b value at 9. And then I'm going down 3/5. So down 1, 2, 3 over 1, 2, 3, 4, 5. Down 1, 2, 3 over 1, 2, 3, 4, 5. Okay, and then from there, you can see that these two points, or sorry, these two lines intersect at that point right there, which is 5, 6. Okay, that is where the two lines intersect. That coordinate is my solution. So because this is my x value of a coordinate, which in this case is my L value, and this is my y value of the coordinate, which in this case is the d value, that means that my solution is 5 lunches and 6 dinners. Okay, that would be your answer in this case. You do have to actually write out like what lunches and what dinners are if you haven't just used X and Y. Okay. And then of course the last step is just to verify that. So let's flip over to the next page. So your last step is to verify your solution that you had 5 lunches and 6 dinners. I've gone back to the original 2 equations that I wrote in order to verify this, but you certainly could verify the equations in y equals mx plus b form. I just don't like working with fractions, and this one was in a fraction or had a fraction, so I went back to the original equations. So in this case, for the first equation, I just have to say that 6 plus 5 equals 11, 11 equals 11, left side equals right side. So the first equation is verified. For the second one, 12 times 5 plus 20 times 6 should be 180. So 12 times 5 is 60. 20 times 6 is 120. So 180 equals 180, left side equals right side. So we have verified with both equations that this is the correct answer. Okay, so that's all that you'll be doing today is graphing some lines and finding the solutions of your equations that way.